Students, welcome you all to another session of the NEET 10, the Game Changer program by Sri Chaitanya, myself Dr. Pavan Kumar Kasu, and I am your chemistry mentor, teaching you the concepts through the numericals or the question that we take up from the FAQs, previous year questions. Alright, so since the beginning of the session or for the last 6 sessions, there had been an immense follow-up from the students, and it's really commendable that you guys had been giving the wonderful answers, and so good to see you back, Rebecca and Ashley. Good evening all of you. So let's start the session without wasting your time. All right, so you know the timings of the upcoming session. You see the first question that I'm going to discuss is from the structure of the atom. You can see Rydberg equation had been the trend, isn't it? You know, when you look at the questions, you will see most of the questions are asked from what? The Rydberg equation, isn't it, right? So I hope you will easily solve the question related to the radius of the second Bohr orbit, whereas the first Bohr orbit radius is given in terms of what? A naught, that is 0.529 angstrom. So you know that radius of the nth Bohr orbit, we generally write it as what? 0.53 into n square by z angstrom, isn't it? Over here the 0.53 is being mentioned as what? The A naught. So you have to express your answer in terms of A naught. So you could see that Rn is equal to A naught into orbit number. N is what? The orbit number. You guys can make out that the second Bohr orbit. Here I want to tell you something which is very important. You see, they might give you directly the orbit number, or sometimes they would say that first excited state. So remember, ground state means n equal to 1. First excited state means n equal to 2, and so on. So remember this, dear students, don't commit a mistake. Check the question properly, whether you are given the orbit numbers or first, second, third excited state. Good evening all of you, welcome you all, right? So n equal to 2, and you know for beryllium, the value of the atomic number is 4, and this gets cancelled and turns out to be how much? A naught. So first question answer is very simple. If you are getting this answer, well and good. That means your follow-up in physical chemistry, which is considered to be the difficult part for the students who are preparing for NEET, you got the right answer. Great going. Now let's see the second question. What do you all say? C. Monima. Brilliant. Bete. Which among the following has more number of lone pairs on the central atom? There is one formula which I discussed in the last session. You have to find out the central atom's X value. Central atom is the one. Rebecca, you were absent yesterday, so let me give you that formula again. X you have to find out for the central atom, which is equal to valence electrons plus hydrogens and halogens attached to the central atom minus overall charge by 2. So follow this formula, which will give you the information about the number of lone pairs, hybridization, geometry. Remember, one formula, 3 benefits. Alright, so please watch yesterday's video for this formula. Valence electrons of xenon, it belongs to 8th group, plus 4 halogens attached. There is no charge by 2. Alright, so you can see that this value is turning out to be how much? 8 plus 4 by 2, which is equal to 12 by 2, which is 6. That means hybridization is sp3d2 minus number of atoms represented as the bond pair gives you the lone pair. So you can see that xenon has 2 lone pairs in XeF4. Now if I give you the structure, you know, according to sp3d2 the geometry is octahedral, and since there are 2 lone pairs, after placing which you will get the geometry as square planar. So left out geometry is square planar. So this is how you will be predicting the lone pairs, hybridization, geometry of a given compound by using a beautiful formula, that is finding out the value of X of the central atom. Monima, it's a great application, please believe me. Likewise, shall we apply for the other? SF4, yesterday you have seen valence electrons plus halogens attached by 2, 5 minus 4, which is equal to 1 lone pair. So you can see the number of lone pair that are present on sulfur is 1. Here they are 2. Alright. Next, boron. Valence electrons of boron, you know that it belongs to third group, plus halogens attached are 4, minus of charge, minus of minus, that is plus 1 by 2. So you can see this is turning out to be 4, and atoms attached to fluorine are 4, so 0 lone pairs are present, right? And this is printed same as XeF4. Alright, so you can see maybe it is XeF6 then. That is why lone pairs are 1. So you can see maximum number of lone pairs that are present in the given case are present with xenon in XeF4. A great answer. BF4 is 0, SF4 is 1, Ashley talks. Brilliant. What an answer, Sarji. Freezing point is least for, remember buddies, once you write all colligative properties, I want to generalize this. I want to give you some input related to this. Listen. Vapor pressure difference PA0 minus PA, alright, is equal to I times of PA0 into XB, isn't it? Delta TB minus TB0 is equal to I times of KB into molality. Delta TF0 minus TF equal to I times of KF into molality. Lastly, osmotic pressure pi is equal to CST. Remember this. You will include I, Van 't Hoff factor, if your electrolyte solute is present, right? Consider if I is high, alright. You know that I is nothing but the number of ions produced by 1 mole of salt. You know, I for non-electrolytic urea and glucose, the I value is equal to 1, and I, Van 't Hoff factor for this, because there are 2 ions that are possible, I is equal to 2, and over here you can see 3 ions are produced, so I is equal to 3. So this is a general thing that we know. Now what if I is greater? Suppose if I is high, you know that now you can see the cases, right? I of BaCl2 greater than NaCl greater than urea, which is equal to glucose, because both are non-electrolytic type. So I value is 1. Monima, good answers, right? Brilliant. Let us check. Suppose if I value is high, you can see what all can be high. Listen now carefully. If I is high, what all values can be high? Let's check. You can see if I is high, vapor pressure, you can see the difference, right? Difference is directly proportional to I, means vapor pressure is low. Remember, vapor pressure is low. Mathematical application. Alright. If I is high, difference in the boiling point. This value, boiling point of the solution is high. Boiling point of the solution is high. Remember this. If I is high, freezing point of the solution is low. Alright. If I is high, osmotic pressure is high. That's it. So this is something that you guys have to remember. Alright, all of you. Come on, let's see. What is asked? Freezing point is least. You can see freezing point will be low if I is high. That's all. And Monima gave great answer. You can see that for this same value of molality, BaCl2 has the highest value of I, hence freezing point is lowest. That's a brilliant answer, buddy. Anyways, good going. 1 Faraday. Look at electrochemistry question. Since we are scared of what you call the physical chemistry, let's emphasize there. Monima gave the answer. Rebecca also said something. 1 Faraday always deposits or liberate 1 mole of any substance in appropriate electrode. Remember, not 1 mole, 1 equivalent. Always remember, 1 Faraday, which is equivalent to 96,500 Coulomb, will deposit 1 equivalent. 1 equivalent means equivalent weight many grams. 1 Faraday is always equal to equivalent weight, not molecular weight. 1 equivalent. People think that it is 1 mole. No. Equivalent comes when you divide, the equivalent weight comes when you divide molecular weight with n factor beta. So they are not same. Okay, so that is not correct. On dilution of acetic acid solution, its molar conductance decreases, specific conductance not at all. Remember, always upon dilution, molar conductance equivalent conductance increases because there are more number of ions which are formed, isn't it? Upon dilution, alpha increases. If alpha, degree of dissociation increases, concentration of ions increase, therefore conductance increases. Maybe Rebecca. Therefore, conductance increases, but specific conductance or conductivity decreases because number of ions per unit volume decreases. No matter which electrolyte you take, K decreases, remaining conductances em होता है पेరుగుताई बढ़ेंगे. तो क्या होगा? Statement 1 and 2 are false. That's a brilliant answer, Rebecca. I think you understood, isn't it? Now 3 guys are giving answers, right? Ashley, Monima, good to join. Rebecca, skillful player, is on the track. The differences between what is what and when the combustion of 1 mole of methane is carried out at room temperature, maybe delta H and delta U. Something is missing here, right? Maybe delta H and delta U, because you can see the answers are in the terms of RT. You see, what you are burning here is methane, isn't it? CH4. When methane is burnt, you know methane is a gas, you need to mention, specify, gives rise to what? Carbon dioxide, which is a gas, but H2O is liquid after cooling to the room temperature. You know delta N is equal to, first you have to balance this equation, right? 4 hydrogens, 2 I will write here, oxygens are 4, 2 I will write here. So delta N is number of moles of gaseous products, minus number of moles of gaseous reactants, which is equal to -2. So delta H is equal to, you know, delta U plus delta nRT. So when you substitute here the value of delta N, you can see delta H minus delta U equal to -2RT. So this is the point that, yes, what is the answer, buddies? What the answer, isn't it? Siddhant. Okay. 90% of a first order reaction is completed in 120 seconds. The time required for 99% of the reaction to be completed in minutes. Let's solve. You know first order reaction, so K remains constant. So let me take the scenario where we are comparing the K for 90% and 99%. K is equal to what? 2.303 by T. Time required for 90% of the completion is given as 120 seconds. You know K is equal to, what is the formula? 2.303 by T log initial concentration upon final concentration. These values you are trying to substitute, isn't it? Let's up. You got the answer also. Ashley talks, crazy fellow. Fellow or filly? Let's see. Log initial concentration, let's assume as 100. Always remember, when you are given the data in percentages, is always good to assume the initial as 100. Remember this, alright. Initial I will assume as 100. You can see 90% is over, so remaining will be 80 will be 10%. The K will remain the same. This is all, this whole data is for 90% completion of the reaction. And for 99% you can see, you have to find out the time. T you have to find out. Log of initial assume as 100. You can see 99% is over, so left out is how much? 1. Now we have ended at this scenario. Okay, that's okay. Let's understand the concept, right? You know, whenever you are finding out anything related to the time, make sure that K is being equated. K remains constant. This is the whole concept or crux of the story. So what will happen here? Let me explain you the calculations. When you get log terms, how would I cancel that off? You can see that 1 by 120, 2.303 is gone on both the sides. Log, this value tend to be what? 10 is equal to 1 by T log 100. You can write it as what? 10 square. 100 can be written as 10 square, isn't it? Now listen all of you. 1 by 120 log 10 is equal to 1 is equal to 1 by T into log 10 square can be written as 2 log 10, whose value inherently is again equal to 1. Alright. Therefore, when you simplify this, you will be getting your answer, isn't it? Hope you understood, Ashley, Rebecca. Monima, got it? Will you do it? Alright, even I explain you the calculation part. If you want, you can pause it later and check through. Now you see the next question is also on chemical kinetics, and you know, when you write the rate, you have to express this in terms of the stoichiometric coefficient. Always understand that whenever you are explaining in terms of the stoichiometric coefficient, always inverse the stoichiometric coefficient ahead of the change in the concentration of that particular component. So minus 1 by 5 d Br minus by dt inverse with stoichiometric coefficient is equal to minus d BrO3 minus by dt, because mostly it is expressed in terms of what? H plus also. Minus 1 by 6 d H plus by dt. So this is the rate expressed in terms of the concentration change of the reactant, hence it is all minus. You just match out to the given data and get your answers accordingly. So you can see what is the answer, right? d Br minus by dt is 5 by 6 times of d H plus by dt. However, here we need to understand that they are stoichiometric coefficient, that means that indicate mole ratio. Alright, that means by chance if mass is given, suppose if they give you in this question as some 1 gram of Br minus is reacting, then how many gram of H plus is consumed? So don't say that for 5 it is 6, for 1 it is 6 by 5. Don't say that if that is mentioned in gram. Please convert that into mole, because stoichiometric coefficient do not represent the mass ratio, it indicates the mole ratio. So in that case you have to write this as 1 by atomic mass. So this many mole. 1 mole gives rise to 6 by 5. Then this will be 6 by 5 times of 1 by 80 mole. And mass of H is 1. 6 by 5 times of 1 by 80 gram. So this would be the answer. So sometimes in order to confuse you, they might give it like that. So don't fumble. Alright, I think you understood. This is very, very important. They will cheat by giving the data in such a way that you commit a mistake. So if they give you 1 gram, don't be misled. Be careful. This is not mass ratio, this is mole ratio. Not only you should get the answer to these type of questions, you should be careful. Hope you understood. Usha, this is a basic question, isn't it? I am vexed up. I saw this question tens of times in tens of the entrances. Which of the following concentration term is independent of temperature? हाँ, NTA bouncers आस्ले क्या term use करते हो यार तुम? NTA bouncers. NTA is nowadays making so many mistakes. NTA is nowadays what you call throwing so many no balls. And don't get panic, because those questions will be added the bonus marks or they will be deleted. So be careful, because you are asked 200 questions which you have to look, understand, solve in 180 minutes. So it's going to be a tough task unless you see the crux of a question. What is asked? Just straight away I is what is asked. If you see what is asked in the question, the familiarity index will increase and your answers will come easily. Look at this concentration terms, you know, mole fraction, temperature dependent, except, you know, all these terms are volume dependent, and volume is affected drastically when temperature is changed. Hence, volume dependent are not taken if temperature is involved, and A is taken, right? Next, protein upon hydrolysis gives alpha amino acids. What do you say? What do you think about this biomolecule, isn't it? Happens to be the important chapter. Can you please say me? A lag raha hai answer 1 and 3. You know that, right? Protein have the peptide bond, and these peptide bonds are broken in the alkaline medium. Saponification बोलते हैं इसको. Alkaline medium में जल्दी होता है. This happens easily in the alkaline medium, right? So it's called as saponification. is also called as causticization or caustication. One and the same, don't get confused. Any reaction that is catalyzed by B, a base, is called as saponification. In this particular case, when you place your hand in soap water, after a while you will see it has developed the crumples, isn't it, wrinkles. That's called as causticization, because your skin proteins are washed away when alkaline medium is provided. That is why don't use soap on face. It will become pale because skin proteins are washed away by the soap. For face, you always use the soap whose pH is less than 7. Beauty tip. Alright, buddies. So, protein upon hydrolysis gives rise to alpha amino acid. Yes, glycis is an exception. Brilliant. Kya baat hai bhai? All alpha amino acids contain NH2 group. It's a boomerang, isn't it? Many people will say, sir, yes, sir. No, sir, this is having what? NH3 place, right? It's a Zwitter ion, isn't it? What an answer, yeah. I need to learn from you, right? You know much better chemistry, Ashley. Amino acids with equal number of amino and carboxyl groups are neutral amino acid. Looks to be correct, isn't it? All naturally occurring amino acids are optically active. It's not mandatory, alright. So 1 and 3 looks to be the correct answer, like someone said. Someone gave the answer in the meanwhile. Rebecca said, yes. Brilliant, and Ashley already told. Yes, next question, alright. Check out the next question. Whenever I see oxygen, poor fellow, last in the race, that clearly indicate that probably it suffered the backlash from the existing electrons which are repelling the incoming electron, because of which its electron affinity. Yes, that's the beauty of your preparation, I could see that. So oxygen gone lost means it is nothing but electron affinity, buddy. So C का matching हो रहा है किसके साथ? Electron affinity के साथ. So C is matching with 1, all right. Next, everyone knows electron negativity. Third, D is matching with 3. There's a tie, isn't it? So D is matching with 3. So the fight is between the first two, right? So you can see when we are talking about the ionic radii in the gaseous state, who will give the right answer? 2. What do you mean by 2? Matching. Yeah, you can see C is 1. Yes, these two are ruled out anyways. So D is 3. So these two are ruled out, no? So what are ruled out? 1 and 3 are ruled out. So we are left out with this, right? Okay, then we will see, right? Next is ionic radii. As there is more positive charge, the size decreases. So silicon with more positive charge is supposed to be having the least size. That is the only parameter, right? That's all right. So A is 2. That's all. A is 2 matching is only 1, right? Because in NEET usually you will find at least in 2 options 2 things will be matching. If you are writing any CET like AP, Telangana, any other state, you will see 1 matching and that will tell you the answer. Okay, but in NEET exam at least 2 you have to cross check. You can see here 3 we have to cross check. Oxidation state of chromium in butterfly. You know that this butterfly is very famous for its oxidation state of chromium, number of peroxy bonds, and its blue color, isn't it? And reaction of potassium or sodium dichromate with H2O2, a famous compound. And it is not plus 10 but is plus 6 because there is only 1 oxide, remaining 4 are peroxides. We know this, right? Blue color solution. Popular thing. Fructose is a reducing sugar. We all know, because what will happen there is the fructose, which is basically having alpha hydroxy ketonic structure, would be converted into the gluconic structure in the alkaline medium, which is indeed giving rise to the tolerance test. So alpha hydroxy ketone fructose is in equilibrium with the glucose structure, and that gives what you call the test. So fructose is a reducing sugar, looks to be a correct statement, but fructose is an aldose is a wrong statement because it is a ketose. So assertion is correct, reason is not correct. Gave the answer. Moksh is typing in Telugu. I know I'm pretty good Telugu, isn't it, right? Moksh. Brilliant, easy. Anta maryada unnanduku santoshanga undi nanna. Chalo, which of the following is not an essential amino acid? Can anyone tell me what is the answer for this? Cheptara beta. Not an essential. Arey vah, Australian talks. Glycine is not, because remaining all you need to understand that, right? Good. 1 mole of NaCl, yeah, please listen here. I want to explain you the concepts related to this, right? What will happen here when you take a particular solid. First, you need to, listen to me. When you have taken listen to me please. When you have taken a salt, you know that there are strong cohesive forces, lattice forces between Na plus and Cl minus. You have to break it first. First, you have to supply some energy so that Na plus and Cl minus are separated. Right? Lattice energy. You can see lattice energy is given. And after that, when you add excess of water, you see water which is doing, when you add excess of water, this is hydrating the ions, right? Na plus and hydrated. So the point is here, there are two components which are involved in the process of converting from NaCl solid to NaCl aqueous is two. One, you have to break the bonds here, that is lattice energy, which is given as positive. Second, hydration energy is negative, right? Because when new bonds are formed with water, you can see energy is released. Here energy is released, negative value. Here you need to supply the energy so that plus and minus separate. First you have to separate the cation anion, then you have to hydrate them. Two process. So overall, the heat of solution can be written as the sum of the lattice energy and hydration energy. One is positive, how much? 788. The other one is negative. Hydration energy is always negative because it is the energy released, because the ions are surrounded by water molecules, new bonds are formed, energy is released, minus 784. So you can see overall plus 4, yes, plus 4 kilojoule amount of energy is taken by NaCl while dissolving it in water. That is why it is called endothermic salt. That means you take glass full of water, add a bit of sodium chloride salt, you can do this experiment at home. Challat neel తీసుకోకండి, take normal water, mix some salt to it, thoroughly stir it, mix it. You will feel little cool. It will not become cold salt water. It will become cooler because that is an endothermic salt. It has taken heat from your body. Endothermic salt, brilliant. Whereas if you do it for calcium oxide, calcium chloride, heat will be released. Exothermic salts. Easy question. Hydrogen electrode with pH 10, oxidation potential is being spoken about. So you should write oxidation reaction plus 2 electrons. Alright. The oxidation potential is asked. EMF is E0 is 0 for hydrogen electrode, minus 0.06 by 2 log of concentration of H plus square by partial pressure of H2. Nothing is being spoken about H2. So take the atmospheric pressure as 1. Equal to, don't do any calculations right now at this junction. 0.6 by 2. You can write this as what? 2 into log H plus. Don't do any calculation, don't put anything. Just listen to me what I do here. Equal to, most of the questions will be like minus log, you can see minus is here, log H plus is here. So you can see if I spare this value can be written as what? pH. So this is another equation to find out the EMF of the cell if pH is given. Just straight away you can put it like that, right? You can see straight away you can put it like this. Use this equation if the questions are asked. So you can see 0.6 is nothing but 0.59. Here the options are in 0.59s. So what's your answer? What is equal to 0.059 to be precise into pH value is given as how much? 10. You substitute 0.59 is the answer, isn't it? Plus 0.59, please understand, not minus. Okay, Karthik. Bond dissociation enthalpy of chlorine is greater than that of fluorine. How many of you agree with this? Yes, shortcut Ashley. Could you please tell me, is this correct? And if it is yes, you should also give me the reason, buddy. Let this class be helpful to those who have not studied these concepts thoroughly. This last 3-4 days is very crucial for you. Last 10 overs of the IPL match. Tell me, is it correct? Is it correct? Chlorine is greater. Yes. Ashley said yes. Moksh. Cheppana. Cheppandi Mokshi garu. Rebecca, what's your answer? Would you please tell me? Usha? Yes. May I know the reason why, Usha? Can anyone tell me, buddies, please? What's the reason? You know, reason, wherever there is resonance, wherever there is back bonding, that bond is considered to be stable one. What will happen here in case of chlorine? You know that each chlorine or halogen carries 3 lone pairs, isn't it? Same is the case with this chlorine. But at the same time, the other chlorine has the empty 3d orbital. Empty 3d orbital. So what they form is p pi d pi back bonding. Maybe this is the reason why the bonds are assumed to be stronger in chlorine. Moksha. There is back bonding in Cl2. Bonds are stronger than fluorine. Have you understood? So this is correct statement. Bond dissociation enthalpy is greater than that of fluorine. This is correct statement. Have you understood, buddies? No, that's what you're talking about. Ashley is about electron affinity. That's a different thing. This is bond energy. Is this understood, all of you? Why Cl2 has more bond energy? P pi, D pi, back bonding. Have you understood? Come on, speak out. Ashley, Somya. Yes, fluorine is stronger oxidant compared to chlorine. You know, I have told you multiple times, fluorine has more tendency to absorb electron because it's more electronegative naturally. Looks to be, this is also correct statement. Stronger oxidizing agent. They will specify aqueous solution is an extra information to confuse you. NEET bouncers. Don't get confused. Aqueous medium lo yedo aipotadi. Em gaadu beta. It's simple. Try to understand. Nothing will happen. In aqueous medium only we are supposed to carry out the reactions, right? It's not that I am throwing fluorine in the air and some other substance in the air and they will react in the air. No, no. These are not Balakrishna fights. They will take place in aqueous solution only. So don't get misled by the statement. Let's see. Moksha. Melting and boiling point higher for chlorine as compared to fluorine looks to be alright. See, when we listen to me, we think like this. Sir, fluorine is a liquid. Chlorine is like someone is already mentioning in the comments. Someone is already mentioning, right? Let me tell you, buddies, we are comparing here for all liquids only. When I say boiling point, that means all liquids. When I say melting point, that means all solids. No matter what, the boiling point is supposed to increase with increase of molecular weight or dispersion forces, because halogens does not have any dipole forces because they are not polar. They are non-polar. They have only London forces, dispersion forces, which are very weak, which are directly proportional to the surface area, size. Therefore, iodine has greatest. or chlorine has higher than fluorine. Got it? So melting and boiling points are greater than. Alright, all are correct. I was a little bit skeptical about the last option. Standard enthalpy of formation is 0 for all elements in the standard state. Elements in the standard state, it is taken as 0. Is taken as 0. It's a convention, buddies, like freezing point of water, boiling point of water, atmospheric pressure, they all are fixed as round figures. It's a convention. That is not a concept at all. You know, for element in the standard state, I2 is a solid at room temperature, bromine is liquid at room temperature, nitrogen is a gas at, not for compounds, for elements in the standard state. That's a brilliant answer, Rebecca and Ashley. Which of the following is an extensive property? Can anyone give the answer? Extensive means what? Energy, right? E for extensive, E for energy. Remember, elections are due in the recent times. Electronic voting machines play the major role. For us, EVM means energy, related terms, volume, related terms, and mass, related terms are extensive properties. Remember this way. Alright, Gibbs free energy, enthalpy, they will give like this, molar heat capacity, etc. blah blah blah. Pressure is intensive, no? It is independent. For the gas we are talking about. Don't think that PV equal to nRT, sir. P is directly proportional to number of moles. No, not like that. This is the contextual thing in reference to something. So, okay, Moksh, do you understand what I said? Did you understand my intent? Density and all that, you see. Density equal to mass by volume, sir. Density varies with mass. No, this is not. This is in the context of something, you see. Referential or contextual. In reference to these properties which are mass dependent, others are not depending that much. In thermodynamics, you don't study in the context of liquid solutions. In liquid solutions, you know, density can be written as mass by volume. For stoichiometry, you will write it. For thermodynamics, it is not like that. If you take a system, the whole system will have the density value remaining constant throughout the process. That is the system which we are taking into consideration. It is not the substance which is present in it. Amount of the system. Alright. Radioactive lanthanide. Theoretical question. Promethium is a beta emitter. Promethium. I checked it in Google only. I am not saying this with my prerequisite knowledge. You need to have information regarding such type of questions. Otherwise, who knows what is radioactive, isn't it? I will say that because I have seen this answer. For you, you need to be careful, right? There are certain things that you need to understand. Please understand this fact. Least acidic, okay. You know that acidic strength increases with electron withdrawing group. So, whichever has withdrawing group will be most acidic. Now, you see you are given some compounds here, you need to ascertain which one is more acidic. Chloroacetic acid, acetic acid, propanoic acid and phenol. You know that phenols are more acidic because of the stability of the conjugate base. There comes the electron withdrawing group, chloroacetic acid, more withdrawing chloroacetic acid. Yeah, chloroacetic acid is more. I am sorry about this. Acetic acid, no. Carboxylic acid, okay, not alcohol. Carboxylic acids are more. Chloroacetic acid, CH2Cl, COOH. Phenol comes later only. Yes, thank you. Less acidic, yes, correct. So, chloro, then you have acetic acid. More the electron releasing group, less is the acidic. But here the plus I effect will increase because more number of carbon atoms, and you guys have immediately caught up. My mistake, glad. Carboxylic acids are more acidic than phenols and alcohols. Brilliant. Great going. So least is phenol. Yes. Simple question, buddy. What will happen here? The chlorine will be replaced by the cyanides in A. I don't know why they give these cyclic rings and all that to make it complicated. And after that, when you are reducing that by using hydrogen, cyanides gives rise to the primary amines, right? CH2, NH2. So one carbon atom will be increased in the resultant product. All right, great. So the total number of carbon atoms here are 6 plus 2, here are 6 plus 3. That's how you can easily identify, isn't it? Good job. Oxidation state of bromine in this is a complicated thing, right? You should know it, right? How would I know that? You see, whenever you have more than one central atom, please understand that there could be bridging between the central atom. You should know it. See, bridging might present between, whenever you are asked, sometimes the question is about the cyclic oxide of phosphorus, cyclic oxide of sulfurous, the what you call octoxide of the bromine. When you are asked such type of question, imagine that if it is cyclic, please bridge the central atom with in a ring. If it is a straight chain compound, bridge them directly. So you have total 8. How would you distribute, buddies? 3, because the maximum number of bonds that the halogen can form is 7. PYQ, 7 only, isn't it? Maximum number of bond that the halogen can form is 7. That's how I wrote. And these bromines which are lying at the last, you guys can see, are having 3 linkages with the oxygen atom. So it is plus 6, and this is having only 2 linkages with the oxygen atom. 2 oxygens minus 2 into 2, that is minus 4. Bromine is plus 4, 3 oxygens, 6, 4, 6. You should know the structure, otherwise it will be difficult. Next, optical activity. For a single, it's a statement based question, you can easily read. For a single chiral carbon containing alkyl halide substitution takes place at a chiral center, SN1 leads to racemization. You know that. In SN1 reaction, when you form a carbocation, in this slow step of the reaction, when the carbocation is formed by the loss of these what you call the leaving group, you all know that the nucleophile can attack from either side. You will be getting a racemic mixture. Correct. The attack of nucleophile may be accomplished from either side of the plane. Intermediate carbocation is formed because carbocation is planar. So nucleophile could attack from either sides. However, we need to know that there is partial racemization that is not being spoken about. So reason, no, how could this be B? Ashley, this is A. Yes, Tarun, I'll try to speak as much loud as possible. Please set your volume also properly. Which are the following 6th group hydride? Let me tell you something which is related to this, which is very, very important, but is, remember, bond energy directly proportional to electronegativity difference. Always remember this point. Okay, like you have watched the Telugu movie Resu Gurram. Have you watched, Rebecca, Tarun? I'm talking about the Telugu movie, I think, right? Let me give you the reference of that movie. Have you watched Allu Arjun's popular movie? No? Sir, we are sincere NEET aspirants, sir, and you are asking us to watch the movies. No, I am not asking you. I am giving a reference in which you will see Allu Arjun and his brother will have huge opinion differences. They always fight. But when there is a trouble to his brother, the hero of the movie will stand forth and fight for him. More the opinion declare, like you have siblings, younger or elder at home. You fight all the time. Cat and mice fight at home. But if there is any problem to your younger or elder sibling, you will be the first one to stand. Is it so? isn't it? So more the electronegativity difference, stronger is the bond. అలా వైకుంఠపురంలో దానిలో ఎవరు కొట్లాడుకున్నారు బేట? అచ్చా అచ్చా ఓకే, ది ఒరిజినల్ అండ్ డూప్లికేట్ ప్రిన్సా మేబీ. సో వాట్ ఎవర్, ఐ థింక్ యూ అండర్స్టూడ్. More the electronegativity difference, stronger is the bond. So when you talk about the bond energy, we think sir HF has least bond energy. No buddies, HF has highest bond energy because their electronegativity difference is high. Similarly, H2O has highest electronegativity difference, but we must say that H2O is stronger in bond, right? Yes, next question I discussed already. F6 hybridization will be a same formula I am using, but listen, valence electrons plus number of halogens attached by 2, 7 and atoms attached are 6, 1 lone pair, hybridization 7 means sp3 d3, 1 lone pair means the geometry is called as distorted tetrahedral. Ammonia, valence electrons plus hydrogens by 2, 4 means hybridization is sp3 minus atoms attached are 3, that means 1 lone pair and it is pyramidal. Alright, BRF5, valence electrons halogen plus 5 halogens attached by 2, 6 means hybridization is sp3 d2 minus atoms attached is 1, that is 1 lone pair, so geometry is square pyramidal. Alright, and ICl4 minus valence electrons plus halogens attached plus charge by 2, 6 sp3 d2 is the hybridization minus atoms attached are 4, 2 lone pairs, so geometry is square planar. That's it. This is the matching. I think you understood the formula. What do you all say? A is 1, B is 3. Got it right? Rebecca, you're going really good bit. Keep it up. I think you guys are understanding, isn't it? What do you all say? Good going. 1, 3, 4, 2. Perfect matching, huh? So that was great. Having a good interaction with you is always like feeling so good. Thank you all for watching. Stay tuned, keep watching. We are going to wind these whole sessions in the coming 3 days. Thank you all.